there is for that way because we couldn't get it to dissolve with the reactor. We took it out of the reactor on a little bit, and then we tried to dissolve it, so we could at least get the dry weight of it, solid percent, and we could have dissolved things on the side. It's stuck to the glass. It's 1,000 pounds over that. Yeah, nowadays it's one of that thing. Yes, if I use panel you haven't like released well, I have a pretty decent feel of this one. By one name, $100. Christian McCaffrey and Greg Olson. Greg Olson perfect for Christian McCaffrey, I'll be Greg Olson is down, they're down. So I just want to really do that. Was it 18 week? 8, 6, something like that. I had a 10. Campbell, my dad was Juan Barkley, Camara, and what? I'm in an 18 week. This was like my family. I was like God and stuff. Yeah. So good.
Do you think anyone else feels short?
Not in a reasonable time?
Huh?
Not in a reasonable time?
Okay. Did you put the whole script? Well, there is a how do you predict future? Can you verbally address what should I do in order to predict future of the quantum system? Like yes, so how I'm going to solve it, or how you are going to solve it? So if we function in the future with understanding that we do have the wave function of the past. So what are the steps? Just general ideas. We don't need to be super precise. Anyone? I doubt that you cannot answer because everyone was so successful in the homework based on the grading.
The operators is
Yes, but let's suppose that we have already solved the eigenenergy equation. So we know the phi I of x and we know set of the energies. If we do know the initial condition. So solution is always superposition of eigen functions, right? You can say it without hesitation, right? But we do have time dependence. Where does it come to? So what happens if we have only one eigenfunction and let it go in time? The observables will not change, right? But the function itself will accumulate phase. Okay? If you start from at initial time, if you start from the eigenstate, then in the future it will be the same eigenstate multiplied by E minus I, E I. Okay? So how would you verbalize it? How would Alex verbalize it? If this is past, simple past, and this is simple future. Not in the sense of grammar, but just simple that we do not have other wave functions. If our initial state is eigenstate, then our future will be this same eigenstate times what? Yes, yes. That's correct. Phase accumulation. Right? Now, if we do have superposition of many wave functions, like phi 1 of x, plus phi 2 of x, plus phi 3 of x, at time equals 1, or time equals 0, then after some time lapses, that's fine, but later I'll need to resolve it. After sometimes lapses, each of them enters into the summation with e to the power minus I e1 times t, e to the power minus I e2 times t, e to the power minus I e3 times t. Right? So each eigenfunction accumulates phase according to its own eigenenergy. So if you write summation, which is just adding together stuff, you have this. Will it be correct? What is wrong? What is missing? Yes.
Where am I?
Coefficients. I was looking just for marker of different color, not for coefficients. So, and how do you formulate, where do you find these expansion coefficients? How did you answer this question in the homework? So what if our initial condition, if at time 0 we didn't have like we didn't have third and we didn't have first wave function? What will be the expansion coefficient? So, in order to run this protocol for dynamics, we need to know C1, C2, C3, whatever number of initial states are, right? So, if we are at time 0, we have only this wave function, then C1 will be 0 because it is not contributing, C3 will be 0, C2 will be equals 1, right? So you parse correct eigenstate out of set of initial conditions. Make sense? Please try to help. It's really not complicated. So where are they coming from? Yes. So initial condition is a function, continuous function. And these coefficients are discrete. So you need to convert the initial condition into a set of discrete numbers. So how do you do it? It's not a lecture. I was not planning to speak on it myself. So how to convert initial condition into expansion coefficients? So expansion coefficients are coming by inspecting the overlap of the eigenfunctions and the initial condition. Does it look similar to the vacuum material? No. What is wrong? What is different from the vacuum?
I don't remember that.
How? You don't? Who else do not remember it? Really? Okay, then probably we are going too fast in class. We need to make less of the material and more tricks. It is whatever. So, but if you do have this expansion coefficients, then you can practice your protocol for predicting future. Okay? So we do have the knowledge about harmonic oscillator. No harmonic oscillator. Which model are we doing in the class? What do we do in the class? Which chapter, which subject are we covering?
Including the electron box.
Okay, electron in a box or whatever, particle in the box.
Box.
Huh?
So you said the big title was box.
Yes, the particle in the box. So we do have the set of energies, which will be coefficient inversely proportional to L square, pi square, h bar square, and then 1 square here, and second energy will be pi square, h bar square, L square times 2 square, which will be 4. And the shape of wave functions come from the trigonometric functions, right? So we're just making a little offset. Okay? So if you want to predict a future of the electron in a box, particle in the box, we need to add together to this square root 1 over L sine 1 pi x over L, and this will be square root of 1 over L sine 2 pi x over L. So we need to add together these two functions. So I'm just practicing writing down the same equation, but plugging in real things. So wave function 1, sine pi x over L. First term, second term, sine 2 pi x over L. And each of them is multiplied by e to the minus h bar. I'm plugging here first energy. Pi square, h bar square, L square times t. Second term, e to the power minus I h bar pi h square over t, or L square, times 4, because of this 2 square times t. So we almost have the answer, but what are the missing parts? What is missing in this expression compared to what is there? Well, first our summation runs only over first lowest states, but that's natural. We do not have energy to go further away. We are just at the beginning of consideration. But what else is missing? Yes. So we need to put some expansion coefficients. And what is the condition for expansion coefficients? How do you, if I put, suppose today I feel lazy and I do not want to go into details of computing them, and I just want to guess something for quicker turnaround. So I put some numbers, and you want to judge me and tell whether these coefficients are good or bad.
So it has to be equal but opposite sides.
This was from, I'm pleased to see connections between your words and lecture material, but there, in the lecture material, we derive equation for only one eigenstate, for only eigenfunction for eigenstate, right? Now we are adding them together. So we need expansion coefficients in front of already certified. Another thing I have forgotten is the normalization. But we have certified eigenfunctions, phi 1 and phi 2. And we are missing expansion coefficients C1 and C2. So guess of Alex was that we have C1 plus C2 equals 0. What is the, it's wrong. Do not record it, or record it and then write it is wrong. Additional condition for expansion coefficients come from the philosophies that we have only one electron. So the wave function, time-dependent wave function upon normalization should still give 1. And if we perform normalization, which I do not want to do it, and we do not have time, but if we normalize this function, meaning take imaginary conjugate, multiply, integrate, all sines and cosines will be integrated out, and we will get only combinations of C1 star C1 plus C2 star C2 plus so forth. And by normalization, it should go. It should be equal 1. Or if we do not want imaginary coefficients, we can, or generally, C1 square plus C2 square equals 1. So if you want to play simple game, just as an example, which pair of numbers would multiply this condition, would satisfy this condition? I believe in it. Give, well, since it is only one equation and two unknowns, there are several solutions. But give me an example. Very simple. 0 and 1, yes. So possible initial condition is C1 equals 0, C2 equals 1, which means you have excited your electron in a box from first ground state to second ground state. Or opposite, you can keep it in ground and then have first excited. But eigenstates are boring. I know they are part of any course, but they do not change much in time. So the interesting thing, if we have both of ground and excited coexisting simultaneously. So what if we demand that by absolute value C1 equals C2? What will be the answer? What C will be equal to? Yes, perfect. If you ever open any textbook in quantum theory, you'll see this test expansion coefficient everywhere. So why don't we try just replace this C1 and C2 by square root of 1/2, because we do not need to torture each other too much with complicated things. We just need to try something to see how mechanics is working. Okay? So the goal of today's meeting and the goal of the homework that I hope you will bring on Friday, well, the actual work is nothing. You just run the code, make screenshots, and put it in PowerPoint and bring it to the class. But I really want that you do it in a literate way. Not as robots that just follow the operations, but that you can explain what is going on by human words. Okay? So how does anyone has the formulation of the homework for Friday? What is asked there?
Part 1.
Yes.
Consider electron in a 1p box in the belt. At time 0, it resides in the superposition of ground state and first excited states with equal probabilities.
See, stop. See, it is what we already did. Right? So we modeled superposition of ground and excited state with equal probabilities. So if expansion coefficient is square root of 1/2, then probability of being ground state and excited state is 1/2, right? Square of this, so 50% in ground and excited. So we kind of done half of the homework. But please try to explain it a little bit in human language. Thank you. Can you please continue?
Find expectation values of position operator as a function of time using a MATLAB code.
Okay. How do you interpret the? Anyone has interpretation of this assignment? Or it is too much?
Isn't that saying find the Gaussian distribution over time?
Find distribution, probability distribution. It doesn't need to be Gaussian. And you will see it will be not Gaussian. Okay? So I'll probably need to erase thing there and write more. So we are going to write a code that will implement this prediction of the future and give us wave function at each point of time and space. With your skills in MATLAB, it is nothing. It is really easy on one hand, and on another hand, you already have this script, right? But what do we do if we have an array of data for this any position in time? So first, we are going to multiply it by itself. So we are going to take star, multiply it by xt, and this will be probability distribution, P of xt. Before going anywhere in observables, and you may want to plot this function. This is a simple thing, but it will look very colorful, and it will help you to get an idea of what is going on with the system. It will develop your intuition, and you can answer many questions intuitively right away after you plot this thing. So we will spend time on looking on this stuff in numerical form, and then later go to what Alex assigned to us. Well, Alex did reading. Right? So how do you find expectation value of position? It's postulate number 5. No. Maybe you do, I don't. Suppose that you know wave function. Huh?
Do you normalize it?
Suppose that wave function is already good, normalized. If you start with normalized expansion coefficients, 1 over square root of 2, everything is normalized. Once I was calling it a bridge between fantasy and reality. So what is this equation for expectation value?
Not that Aaron first theorem.
First, it is you are thinking in a right direction, but Ehrenfest's theorem is more detailed thing. It is how to connect quantum theory with classical theory, how to reproduce Newton's equation. But we are looking to simpler thing. Like if you do have wave function, and you know that operator of position is just x, we multiply wave function, conjugate wave function itself, and integrate it over position. So if we know wave function, if we form this operation, as a result, we will get position which may or may not depend on time. And the main take-home message, or not take-home message, main scientific question to the problem that we are going to explore with method today is whether position of electron will stay constant or it will move. This is a really important question in the following sense. So if you do prepare your quantum system in the eigenstate, if you tell that all except one coefficients are zeros and one coefficient is 1, then if you practice this equation, you will get some answer that will not change over time. So if system is in eigenstate, then expectation value of most observables, including position, will be a constant. Most likely, it will be right in the center of the box, right? So if you have the box, you have electron, and it will be whether you have first harmonic, second harmonic, or something complicated, expectation value will be right in the L over 2, right? In average, electron is at the center. But we are going to question this conclusion in case of superposition. So constant or not constant? So let's quickly go over the code and then probably try to run it. But you may have already looked and run the code. So we define size of the box, just to be simple, although it can be generalized. We define the grid points for position, and then we already plug in the equations for first and second states, for ground and excited state, right? So it is what we did in the class. And when you run the code, first thing, it will just pop up on the screen. So it's not a big wonder, the sign with half period and full period. And then, as you go through, if, in case you are going to explore the equation for expectation value, where this symbol psi means summation of eigenfunctions, right? So there are two terms here and two terms there, right? So what will be the total number of terms? Yes, 4. And each term will have products of wave functions. So what we may try to do is just to write more or less elegant code so that we do not repeat writing of this product of wave functions again and again. We can define, if we multiply first by second, it will be R11, second by second R22, first by second R12, second by first to psi2, psi1, right? Just because it will pop up later. And then we can plot how these products will look like, just to know with whom we are dealing in sense of the functions. Then if there are no time dependency, if we are looking on the probability distribution with p of psi star times psi at time 0, it will be just first and term where we have product of first wave function of itself and second wave function of itself with probability 1/2. But as time will pass by, well, there is no cheating, but I did some derivations, which we will probably do in class. I didn't realize until we were here. So if you take probability distribution of such wave function, you will see that some of these exponential phase factors will cancel. And some of them will contribute to trigonometric functions. So for terms where the indices are the same, the phase accumulation factors will cancel. And for those where the indices are different, the phase factors will convert into a simple trigonometric function. So I am asking you to believe it and accept it, but we will do it either in class or as a homework. I prefer it in class, so that homework should be easy when possible. Okay, and this expression R at each time, it will be actual the probability distribution at given time. So we will open a cycle over time, going over like 3 periods, and then generate this probability distribution at each time. So here is the minimal thing. If you were busy or if you were sleeping and you plan doing nothing next second, now please wake up and look. Minimal information. So at each time we generate probability distribution. Therefore we will have several slices of time. At each time slice, probability distribution will be different. Therefore one x will be x-axis or x-axis, and another axis will be time. And the third will be probability distribution. So we will look how the probability of finding electron here or there will change in time. So it is a most funny stuff to look at. Okay, if you are busy with doing some other things or you're tired, you can sleep back. But remember the message. Okay? Now, let's look back on this equation. We can reinterpret it once again, since psi star times psi will be just probability distribution. We can rewrite this equation this way. Probability distribution times x and then integrate. Okay? And this probability distribution is named as variable RR in the code. So when we multiply this probability distribution by x, and we did arrange this prime symbol so they are multiplied as a scalar product. So it means first element from one array by second element from second array plus first and first plus second and second plus third and third. So it will be equivalent to just integration, summation of this product. So in fact, this will be expectation value of position, which is requested in the homework assignment. So there is a comment. Expectation associated with our main question, main scientific question to this lab and to homework. Whether expectation of value of position will stay constant or change in time. So we are going to put a cycle over time, and we are going to recompute this AX for average X again and again at each point of time. And the question will be whether this expectation value will stay the same at each time step, or it will be modified. So here is the little trick. So we are accumulating this AX into variable average X. So at each step, we use old variable and add new element. So the size of this vector grows and grows and grows each time we go. And the same accumulation is going for the distribution. So at the end of the cycles, there will be two variables, AV of X for expectation value of position, and variable S for probability distribution. Okay, let's run and see what happens. Probably you were already running it, but let's do it together. So first it just plots, so here's the box, and here is the ground state and first excited, right? With first ground state and with half period and first excited with full period. Here are these 4 terms which will always contribute to expectation value. So this function which look a little smoother, it is so-called diagonal terms, or where the indices are the same, and this dashes which goes sometimes negative is the product. So first wave function times second wave function. What happens if you hit enter? Huh? Okay, so what does it mean? So the x-axis is position, and y is the probability distribution. So as time passes by, we have more probability either to left or right corners of the box. By the way, from the intuitive expectations, what would happen if you suddenly forget everything from quantum theory? Well, nothing bad will happen, right? And then you throw in a classical particle in the box. What would it do? Like if you have billiard ball between 2 walls and there is no friction on a billiard table. It will, roll to a wall, bounce back, roll to another wall, so it will go forth and back. So the movie that you have observed was the same thing, an analogy between quantum and classical. So the probability distribution will bounce forth and back between walls. And remember, remember you were invited to wake up and listen to something, right? So that we are looking for probability distribution as function of position and time. So it is the same thing as you did observe in the movie, but if you ever decide to do scientific papers, it's not very common to publish movies. But if the color maps distributions are fine to use in scientific communication. So the yellow means it is higher probability to find an electron. And blue means lower, 0 probability to find an electron. So we originally start at left edge, and then it kind of bounces. It doesn't approach right to the edge. It starts reflecting before it touches. It reflects force and back, force and back. So by processing this data with a protocol for expectation value, one may expect that expectation value of position will follow the maxima of these yellow blobs, right? So it will be either zigzag line or maybe some harmonic oscillation, right? So if you hit enter once again, what happens? Nothing happens? Maybe in your version it should be something better.
Double check the window.
Oh, maybe it's additional window, yes. So you're getting something like this, right? So it is expectation value of position. So and it is already normalized. So at time 0, it is, well, average value is size of the box divided by 2, half of the box. So it, potentially it may change from 0 to 1, but you did observe that it never smashes right into the edge. It starts reflecting before coming closer. And it starts a little bit away from center. Then it goes to another edge, then bounces, and bounces again. Okay? So goes left and right, left and right. Ah. What is the homework assignment? Let's ask Alex. Because he's confirmed to have the hardware.
Consider the electron on one box of L that n equals 0 resides in superposition of ground state, excited state to be probability. Find expectation value of position operator as a function of time.
Okay, so this is answer, right? This is expectation value of position as function of time. And this is position, this is time. What is the answer on our original scientific question? Is it constant or not constant? Good. So, how do you interpret your assignment for the rest of the stuff? Make screenshots from of the distribution of this function, put it in Word or PowerPoint, and write some legitimate explanation, as you typically do in other lab reports. Right? At such extent that if we invite external grader, he or she will understand what is going on. Do not be lengthy, but do not write, I'm done what was required, here is my feedback. Do a little bit of explanation, like position, distribution, center, folds, or another group like beyond fold. Clear? Okay, I'll make my plans and make circles around and see if you are happy. And then, if time allows, I will do same thing as Bill did on previous week. I will enter the lines of code that will save the movie. I didn't put it in the whole work, but you all can try to do it. With place the movie on YouTube, send you a link, but it's second. First, screenshots and verbal explanation. So we've been just sitting to if any questions appear. Let me announce that there are some heroes in the class who have already submitted the homework, but since it is not yet deadline, you may those who did it may resubmit with more detailed comments. So if I decide not to grade myself and not to give it for you to grade, but invite some other faculty to be a guest grader, he or she may not be super happy if it is extremely short. So just give a little introduction what you're doing, assuming the reader is not aware, was not part of the discussion. Just maybe a little longer than 3 sentences. Huh?
What did you say?
A little longer than 3 sentences.
Oh.
Yes.
On when we have all the little like mountains, you said that the peak are not exactly on the outside. Why was that?
I may have understood.
So,
Those are the coordinates.
Okay.
And we demand
Okay.
It'd be the same. Like,
Just flipped. Yeah, so.
So it's going on 0 to point.
So yeah, the one, so your x-axis is equal to.
Which is exactly
So yeah, really I think that. Is that sort of. That brings some stuff to my mind.
I see some.
Yourself a $23,000 raise? Kevin Kramer raised his pay to over $93,000 a year, took $43,000 from energy interests, then voted 17 times to raise utility rates. Kevin Kramer, putting himself first.
You know, sometimes we get so obsessed with the big stories of the day that the little story is going to fall through the cracks. Well, I love to get my hand down into that crack and see what I can fish out. In our beloved segment, Meanwhile, yesterday I told you all about Donald Trump holding that press conference backed up by the cast of Reservoir Dorks. But take a look at Treasury Secretary Steve Mnuchin behind Trump while he's speaking. What is it? What is it that he's doing? Is he gonna hock a loogie on Jared? Does he have a hairball? We don't know. Turns out there's a perfectly reasonable explanation once you turn down Trump and turn up Steve Mnuchin's audio. Jimmy, can we hear that, please?
Nobody knew a thing like this could have happened.
Meanwhile, in astronomy news, a skull-shaped asteroid will pass by Earth after Halloween. Well, there you have it. Donald Trump's president, giant skull is appearing in the heavens. Now we just need the oceans to turn to blood, and we can finally check apocalypse off our bucket list. Now, a few points of clarification. First of all, please do not freak out. It's not really a skull-shaped asteroid. It's just a ball of rocks and frozen gas that has lost its luminance after too many trips around the solar system, and it's technically a skull-shaped death comet. Isn't that reassuring? No, honey, it's not a skull asteroid, it's a death comet. Good night. Meanwhile, we have another edition of our segment, Animal in the Human Place. Where did that animal get into this time, Jim? It's a horse in a coffee shop. Yes, a horse in a coffee shop. Why is he putting on such a rampage? Turns out they misspelled his name on the cup. Meanwhile, a battle is raging in Houston, Texas, where the city's mayor is pushing back against a robot brothel that is coming to town. Uh-oh, the robot brothel is coming down the street. The idea makes sense. Who among us hasn't fantasized about patronizing a prostitute that can also destroy you at chess? At this robot brothel, customers will pay for use of the dolls and a private room, and sessions range from 30 minutes up to 2 hours. Totally up to you how you divide that time between sex and weeping over what brought you to this moment. Your Roomba will never forgive you. We'll be right back with Eva Longoria. Welcome to The Late Show. I'm your host, Stephen Colbert. Thank you for that. I need that tonight in ways I don't always need it, because today has shaken me to my core. And I don't think I need to point out that at 54, there's not a lot of core left. It's a nice suit. It gives me the illusion of core. Before we get into whether our president is the Siberian candidate, I'd like to take a moment right now to remind you of something Lincoln said. America will never be destroyed from the outside. If we falter and lose our freedoms, it will be because we destroyed ourselves. And a house divided against itself cannot stand. They were his two most famous tweets. So, with that in mind, I'm thinking that maybe in the interest of unity, the most patriotic thing we can do right now is not pointing out the alarming behavior of our president, but instead just shut up and take it until he's gone. Does anybody feel like just taking it? Me neither. So, here's the thing. I was I was worried. Worried there for just a second. So, Trump's in Helsinki with his buddy Vlad. And this meeting's just 3 days after 12 Russian military intelligence agents under direct Kremlin control were indicted for hacking the 2016 election. Now, 12 agents sounds like a lot, but remember, they're Russian, so they were all nested inside one big agent. Okay? Now, first, the two men had a private meeting with only translators in the room. And to make sure that everybody stayed out, they put this sign on the door, strong men only, no girls allowed. And just before we get into the nitty-crazy of what they said during their post-meeting press conference, let's see how people reacted to Trump's performance, because the reviews are in.
You have been watching perhaps one of the most disgraceful performances by an American president at a summit in front of a Russian leader that I've ever seen.
We heard the worst that we could possibly hear from a U.S. president while standing alongside Vladimir Putin.
You should call this the surrender summit.
This was a worst-case scenario going into this.
Disgusting. That's what made his performance disgusting. I'm sorry, just the only way I feel. It's not a right or left thing to me, it's just wrong.
Wow. Those are the worst reviews I've seen since Titanic. And I don't mean the movie. 1 star, I drowned, great band though. That's positive. That's kind of positive. Kind of positive. You don't hear that part. You don't hear about that part. Well, why so bad? Well, he was asked about Russian meddling with our election and whether he believed all of our intelligence agencies or Putin.
My people came to me, Dan Coates came to me, and some others. They said they think it's Russia. I have President Putin. He just said it's not Russia. I will say this, I don't see any reason why it would be.
You don't see any reason? Do you own a mirror? Because after throwing your intelligence community under the bus just then, you then threw it in reverse and turned them into roadburger.
I have great confidence in my intelligence people, but I will tell you that President Putin was extremely strong and powerful in his denial today.
No, boo all you want, but he's extremely strong and powerful. He does not